National Electrical Code Section 695.6 motor circuits specifically covers the wiring methods for the fire pump motor. Section 695.14 control wiring specifies the wiring methods for control circuits. This likely includes the wiring for the jockey pump. However, Section 695.1 states that this section does not apply to wiring connections between the power source and the fire pump motor, the actuator controlling the fire pump motor, or between the actuator and the fire pump controller. Therefore, the wiring methods listed in 695.6e and 695.14e do not apply to the wiring connections between the power source and the fire pump motor, actuator, or controller. Regarding the question of whether the wiring methods listed in sections 695.6e and 695.14e pertain to all essential fire pump equipment, the answer is no. These wiring methods only apply to the wiring for the pump motor and control circuits. The wiring for other essential fire pump equipment, such as the jockey pump, is not specifically covered by these sections. However, it is reasonable to assume that similar wiring methods would be used for all essential fire pump equipment. For example, the wiring for the jockey pump should be installed in a manner that ensures its reliable operation in the event of a fire. Let's delve deeper into the specific requirements and considerations when dealing with fire pump wiring, expanding on the initial clarification. Firstly, it is crucial to understand the intent behind Article 695 of the National Electrical Code, which is to ensure a reliable power supply to fire pumps. This reliability is paramount for life safety and property protection in the event of a fire. The Code emphasizes the need for robust wiring methods and protection to minimize the risk of failure during fire conditions. Secondly, focusing on Section 695.6e, which addresses motor circuits, the wiring methods specified here are intended to protect the fire pump motor from potential damage due to fire or other adverse conditions. This section typically requires the use of listed fire-resistant cables or raceways encased in concrete. The specific requirements depend on the voltage and ampacity of the motor circuit, as well as the installation environment. Consult the relevant tables in the NEC, such as those in Chapter 3, for approved wiring methods and conductor sizing. Thirdly, when considering Section 695.14e, which pertains to control wiring, it's important to recognize that control circuits are essential for the proper operation of the fire pump. These circuits typically include wiring for pressure switches, flow sensors, and other control devices that regulate the pump's operation. The wiring methods for control circuits must be selected to ensure reliable signaling and control even under fire conditions. This often involves the use of fire-resistant cables or raceways similar to those required for the motor circuits. Now let's address the jockey pump wiring. As noted earlier, the NEC does not specifically cover the wiring for jockey pumps in sections 695.6e or 695.14e. However, it is a sound engineering practice to apply similar wiring methods to the jockey pump as those used for the main fire pump. This ensures that the jockey pump, which maintains pressure in the fire protection system, remains operational during a fire. The selection of appropriate wiring methods for the jockey pump should consider factors such as voltage, ampacity, and environmental conditions. Additionally, it's essential to comply with other relevant sections of the NEC, such as those pertaining to overcurrent protection, grounding, and bonding. To further clarify, let's discuss the exceptions and limitations outlined in Section 695.1. This section explicitly excludes wiring connections between the power source and the fire pump motor, the actuator controlling the fire pump motor, or between the actuator and the fire pump controller from the requirements of sections 695.6e and 695.14e. This means that the wiring from the service entrance to the fire pump controller, as well as the wiring between the controller and the motor, is not subject to the same stringent wiring method requirements. However, it is still crucial to ensure that these wiring connections are installed in a safe and reliable manner, in accordance with other applicable sections of the NEC. Moreover, it's important to consider the coordination of overcurrent protection devices in the fire pump circuit. The NEC requires that the overcurrent protection devices be selected and coordinated to provide adequate protection for the fire pump motor and wiring, while also minimizing the risk of nuisance tripping. This often involves the use of time delay fuses or inverse time circuit breakers, which can withstand the high inrush currents associated with starting a fire pump motor. Furthermore, grounding and bonding are critical aspects of fire pump wiring. The NEC requires that all metal parts of the fire pump system, including the motor, controller, and raceways, be properly grounded and bonded to provide a low impedance path for fault currents. This helps to minimize the risk of electric shock and equipment damage in the event of a ground fault. The grounding and bonding system must be designed and installed in accordance with the requirements of Article 250 of the NEC. In addition to the NEC requirements, it's also essential to comply with any applicable local codes and regulations. Many jurisdictions have adopted the NEC with amendments or additions that may impose more stringent requirements for fire pump wiring. It's crucial to consult with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Let's now elaborate on the practical implications of these code requirements. When designing and installing fire pump wiring, it's essential to consider the environmental conditions to which the wiring will be exposed. Fire pump rooms are often located in damp or corrosive environments, which can accelerate the degradation of wiring and equipment. Therefore, it's crucial to select wiring methods and materials that are suitable for the specific environmental conditions. This may involve the use of corrosion-resistant raceways, insulated conductors, and watertight fittings. Another important consideration is the accessibility of the fire pump wiring for inspection and maintenance. The NEC requires that fire pump wiring be installed in a manner that allows for easy access for inspection, testing, and maintenance. This may involve the use of removable covers, access panels, and adequate working space around the equipment. Regular inspection and maintenance of fire pump wiring are essential to ensure its continued reliability. This includes visual inspection of the wiring for signs of damage or deterioration, as well as electrical testing to verify the integrity of the circuits. Any deficiencies identified during inspection or testing should be promptly corrected to prevent potential failures. To further enhance the reliability of fire pump wiring, it's recommended to use redundant wiring methods. This involves installing 2 or more independent wiring systems to supply power to the fire pump. If one wiring system fails, the other system can automatically take over, ensuring uninterrupted power to the pump. Redundant wiring methods are particularly beneficial in critical applications where even a brief interruption of power can have serious consequences. In summary, fire pump wiring is a critical aspect of fire protection systems, and it's essential to comply with all applicable codes and regulations to ensure its reliability. The NEC provides specific requirements for wiring methods, overcurrent protection, grounding, and bonding, which must be carefully followed. Additionally, it's important to consider the environmental conditions, accessibility, and redundancy when designing and installing fire pump wiring. By adhering to these guidelines, it's possible to create a fire pump wiring system that is safe, reliable, and capable of providing uninterrupted power to the pump during a fire. Remember to consult with a qualified electrical engineer or contractor to ensure that the fire pump wiring system is designed and installed in accordance with all applicable codes and regulations. They can provide valuable expertise and guidance to ensure that the system meets the specific needs of the facility and provides the highest level of fire protection. Also, consider the specific voltage drop requirements for fire pump circuits. The NEC typically limits the allowable voltage drop to ensure that the fire pump motor receives adequate voltage under load. Excessive voltage drop can reduce the motor's performance and increase the risk of overheating. Therefore, it's crucial to carefully calculate the voltage drop in the fire pump circuit and select conductors of sufficient size to minimize voltage drop. The voltage drop calculation should take into account the length of the circuit, the ampacity of the load, and the conductor's impedance. Finally, it's essential to document all aspects of the fire pump wiring system, including the wiring methods, overcurrent protection devices, grounding and bonding connections, and voltage drop calculations. This documentation should be maintained in a readily accessible location and should be updated whenever any changes are made to the system. Proper documentation facilitates inspection, testing, and maintenance of the fire pump wiring system and helps to ensure its continued reliability. Moreover, it's crucial to ensure that all personnel involved in the installation, maintenance, and testing of fire pump wiring are properly trained and qualified. Fire pump wiring is a specialized field that requires a thorough understanding of the NEC and other applicable codes and regulations. Only qualified personnel should be allowed to work on fire pump wiring systems to prevent potential errors or omissions that could compromise the system's reliability. To reiterate, while Section 695.1 excludes certain wiring connections from the stringent requirements of 695.6e and 695.14e, it does not relieve the installer of the responsibility to comply with other applicable sections of the NEC. For example, the wiring from the service entrance to the fire pump controller must still be installed in accordance with the general wiring requirements of Chapter 3 of the NEC. This includes the use of approved wiring methods, proper overcurrent protection, and adequate grounding and bonding. Furthermore, even though the NEC does not specifically address the wiring of jockey pumps, it is still essential to ensure that this wiring is installed in a safe and reliable manner. As a general rule, it is advisable to apply the same wiring methods and protection requirements to the jockey pump as those used for the main fire pump. This ensures that the jockey pump remains operational during a fire and can maintain pressure in the fire protection system. When selecting wiring methods for fire pump circuits, it is important to consider the potential for exposure to physical damage. Fire pump rooms are often located in areas where they are susceptible to damage from vehicles, equipment, or other sources. Therefore, it is advisable to protect the wiring with rigid metal conduit or other suitable means of physical protection. In addition to physical protection, it is also important to protect fire pump wiring from exposure to moisture and corrosive substances. Fire pump rooms are often damp or humid, which can accelerate the corrosion of wiring and equipment. Therefore, it is advisable to use moisture-resistant wiring and fittings and to protect the wiring from direct exposure to water or other corrosive substances. The selection of overcurrent protection devices for fire pump circuits is also a critical consideration. The NEC requires that the overcurrent protection devices be sized to protect the fire pump motor and wiring from overloads and short circuits. However, the overcurrent protection devices must also be sized to allow the fire pump motor to start and run without tripping. This often requires the use of time delay fuses or inverse time circuit breakers that can withstand the high inrush currents associated with starting a fire pump motor. Grounding and bonding are essential for ensuring the safety and reliability of fire pump wiring systems. The NEC requires that all metal parts of the fire pump system be properly grounded and bonded to provide a low impedance path for fault currents. This helps to prevent electric shock hazards and to minimize the risk of equipment damage in the event of a ground fault. It is important to use approved grounding and bonding methods and to ensure that all connections are tight and secure. Regular inspection and testing of fire pump wiring systems are essential for ensuring their continued reliability. The NEC requires that fire pump wiring systems be inspected and tested periodically to verify their proper operation and to identify any potential problems. The inspection and testing should be performed by qualified personnel and should include visual inspection of the wiring, testing of the overcurrent protection devices, and measurement of the grounding impedance. In addition to the NEC requirements, it is also important to comply with any applicable local codes and regulations. Many jurisdictions have adopted the NEC with amendments or additions that may impose more stringent requirements for fire pump wiring. It is crucial to consult with a local authority having jurisdiction to ensure compliance with all applicable codes and regulations. It is also important to coordinate the fire pump wiring installation with other trades, such as the plumbing and mechanical contractors. The fire pump wiring must be installed in a manner that does not interfere with the operation of other systems and that allows for easy access for maintenance and repairs. Finally, it is essential to document all aspects of the fire pump wiring system, including the wiring methods, overcurrent protection devices, grounding and bonding connections, and test results. This documentation should be maintained in a readily accessible location and should be updated whenever any changes are made to the system. Proper documentation facilitates inspection, testing, and maintenance of the fire pump wiring system and helps to ensure its continued reliability. To summarize, the wiring of fire pumps is a critical aspect of fire protection systems, and it is essential to comply with all applicable codes and regulations to ensure their reliability. While specific sections of the NEC may not explicitly cover all aspects of jockey pump wiring, applying similar principles and ensuring adherence to general electrical safety practices is crucial. Always consult with qualified professionals and local authorities to guarantee compliance and the highest level of safety.